All right, we've made it to the last section of Unit 2. This is 9.2 and 9.3, where we talk about the sum, difference, double, and half angle identities. I will tell you right now, it's a hefty section. I encourage you to take this in parts, okay? Um, I would not go all the way through and then try to do these. I would really chunk it, okay? So the goal for today is to use all of these identities to solve and simplify and rewrite and verify. So let's go ahead and just start with what we do know already. We know our reciprocal identities. I'll jot that down one more time. Um, Here we're going to have cosine theta. Here we're going to have sine of theta. Here we'll have tangent of theta. Okay. For our Pythagorean identities, we know the first one would be cosine squared theta. For the next one, that one's with tangent squared theta. And our last one will be with cotangent squared theta. Okay. All of those we've now covered to some extent. It's now time to really introduce even more and start manipulating our equations. Okay. Now, the reason that we really use these guys is because unfortunately life's not perfect and we're not always going to get values that are on the unit circle. Most of the time, you really don't get stuff that's on the unit circle. For example, like 15. If you look at the unit circle, you'll notice that we skipped over anything that is a factor of 15. And so that could also be considered pi over 12. Same with 75, which is also something over 12. It's 5 pi over 12. We don't have those values memorized, right, from our unit circle. So we can use a different rule to solve for that. Okay. Um, and one way to do that is to come up with two other numbers that we know to get to 15 degrees or to get to pi over 12. Okay. So in this case, if we're working with radians, let's see what two numbers we could add up to get to 7 that would end up being convenient values for us to use. I immediately think of 3 pi over 12 and 4 pi over 12, right? That's going to get us 7, but they also simplify to pi over 4 and pi over 3, which is great. At this point, we know a lot about pi over 4 and a lot about pi over 3. So we can use that information to find information for 7 pi over 12. That's really what this section is going to be about. Okay. Those equations that we're going to use are going to be the sum formulas. Okay. We also have difference. We're going to start with sum. Here are your sum formulas. For any two angles or radians, you have A and B. Okay. It does not matter the order because it will follow along for the rest of the equation. You just have to make sure that you don't switch them around halfway through. Okay. If you are doing anything with sine, you have that first one. If you're doing anything with cosine, you have the second one. They are different, so it is important to recognize the difference. You will be expected to memorize this and learn this, okay, and be able to apply it. So let's start by using 7 pi over 12. We've already figured out from earlier that we can use pi over 4 and pi over 3. I'm going to go ahead and zoom in here because we're going to need some space. I will go ahead and start with cosine. I know that I can use pi over 4 plus pi over 3. Okay. This is going to be a sum. So, and it's for cosine. So I'm going to have cosine of A times cosine of B minus sine of A and sine of B. Okay. This is A and this is B. If you wrote it the other way around, that's fine, right? Your equation will look slightly different, but you will come up with the same answer at the end. And now we just need to replace stuff. So I have cosine of pi over 4 times cosine of pi over 3 minus sine of pi over 4 times sine of pi over 3. And now we know these values because we've been working with them so much that we know exactly what they are. Okay. So I know that cosine of pi over 4 is root 2 over 2. Okay? I know that cosine of pi over 3 is going to be 1/2. I know that sine of pi over 4 is root 2 over 2. And I know that sine of pi over 3 is root 3 over 2. Okay. Now, the left side will combine through multiplication, the right side will combine. So we have root 2 over 4 minus root 6 over 4. And to finish simplifying, we will write these together under one denominator. Sorry, over one denominator, okay? So, whoa, that was fun. I've never seen my iPad do that before. So cosine of 7 pi over 12 is equal to this expression. I'm going to go ahead and tell you right now, this expression is going to come up a lot in different formats. Sometimes it's going to be added, sometimes it's going to be root 6 minus root 2. You're about to see that happen with sine of 7 pi over 12. So now we're going to do sine 7 pi over 12. We still are using the same exact values. We're using pi over 4 plus pi over 3, okay? Now our equation just looks ever so slightly different. We're going to do sine of A times cosine of B plus cosine of A times sine of B, okay? And now we plug in what we know. We have sine of pi over 4 times cosine of pi over 3 plus cosine of pi over 4 times sine of pi over 3. Okay? We have that information. We know that sine of pi over 4 is root 2 over 2. We know that cosine of pi over 3 is 1/2. We know cosine of pi over 4 is root 2 over 2. We know that sine of pi over 3 is root 3 over 2. And now we simplify. We have root 2 over 4 plus root 6 over 4. Okay? We can write that all over one denominator like before. And that is sine of 7 pi over 12. Okay? They take a little bit of work, right? The good news is you have all this information now in your pocket, right? You have learned these parts of the unit circle to where you're going to be comfortable pulling that out. Okay? All right, let's move forward. Oh, I realized I wrote very small. Hold on, let me move this to the center. I zoomed in very far. Okay? Now, we want to use for the difference formula, we will go ahead and use, zoom in here, cosine of A minus B equals cosine of A times cosine of B plus sine of A times sine of B. Okay. Now, in this case, X is going to be our A. We're not going to end up with just a single value as an answer. We will have a variable, and that's totally fine. So we have cosine of X times cosine of pi over 6 plus sine of X times sine of pi over 6. Okay. Now, there's not much I can do with these guys, but I can go ahead and simplify cosine pi over 6. Okay, I know that pi over 6 is also 30 degrees, so I know that this will be root 3 over 2 times cosine of x, plus I know that sine of pi over 6 is 1/2 times sine over x. So I can write this on over one denominator of root 3 cosine x plus sine x, all divided by 2. Okay? Let's move on to the next one. Again, this is without a calculator. We're trying to use what we know from the unit circle to help us. If we want to find 5 pi over 12, let's think about some things that add up to 5 that might be convenient on the unit circle. Okay, I immediately think about 2 and 3. Okay, that's going to be pi over 6 plus pi over 4, which does work for us. Okay, we do have information about that. So let's go ahead and treat that as A and B and do our sum for sine. Okay, our sum for sine will be sine pi over 6 times cosine of pi over 4 plus cosine of pi over 6 times sine of pi over 4. Okay, now we need to replace everything as needed. We know that it's going to be 1/2 times root 3 over 2 plus, sorry, root 2 over 2, got ahead of myself, plus root 3 over 2 times root 2 over 2. We'll end up with root 2 plus root 6, all divided by 4. So as I mentioned earlier, we're going to see this expression pop up quite a bit. Um, Anything that's an iteration of 15 degrees is going to have something that looks like this, right? Like I said, it might just be that one is being subtracted and it might be in backwards. Okay. Looking at cosine of 195, let's think about two numbers that might add up to that, right? I immediately think of 45 and 150. Okay, so I know information about that. I know, just FYI, that 150 is over here on the unit circle. So it's going to have the same values as a 30-degree triangle. So I'm going to think about my 30 degrees, except that I'm in quadrant 2. Okay, we're working with cosine. So let's go ahead and write out our cosine sum. Cosine of, whoops, 45 times cosine of 150 minus sine of 45 times sine of 150. Okay. Cosine of 45 is going to be root 2 over 2. Cosine of 150 is going to be negative root 3 over 2. Sine of 45 is again root 2 over 2. And sine of 150 is a positive 1/2. So here we're going to have negative root 6 minus root 2, all divided by 4. And that's going to be equivalent to cosine of 195. Okay. I encourage you to draw the triangle if you're unsure where they are. It always helps. Now, tangent looks slightly different, okay? The tangent sum and difference formulas, all use tangent, no sine and cosine included. And the difference between the sum and the difference is only that the numerator ends up being subtracted instead of added. Other than that, they are the exact same. They are pretty easy to use. Out of all the ones that we're going to be working with, I tend to use tangent the least. So just keep that in the back of your mind. Okay. I would feel really, really good about sine and cosine. So let's go ahead and do both of these. We're going to expand tangent of pi over 4 plus x and tangent of 11 pi over 12. So we'll start with this guy. I have tangent of pi over 4 plus x. So that's my sum. That means I'm going to go ahead and use tangent of pi over 4 plus tangent of x, all divided by 1 minus tangent pi over 4 times tangent of x. Here's the thing. I am very flexible with how far you need to simplify things. A lot of the time, all of the extra work that goes into simplifying really does not do that much for us. And so I'm okay with you leaving it in something that looks kind of complicated. We're going to see that happen with some of these tangent expressions. Um, Tangent of pi over 4, thankfully for us, is actually 1. So we have 1 plus tangent x divided by 1 minus 1 times tangent of x, right? So I don't need that second one, theoretically. So I'm not even going to write it in my final answer. But that is good enough for me. You don't have to do anything else with that. You can leave it in that form, okay? What we're going to see with the other one is that it ends up being pretty messy looking, and I am okay with you leaving it in the form that it is. Okay, so when we get to that point, I'll tell you again, just leave it. Now, let's take a moment to figure out what adds up to 11. I think of, let's see, 2 and 9. That would be pi over 6 and 3 pi over 4. So that'll work for us. Okay. Now let's go ahead and use those to plug in. So this was addition, so we'll do what we did earlier. We're gonna have, let's see, tangent of pi over 6 plus tangent of 3 pi over 4, all divided by 1 minus tangent of pi over 6 times tangent of 3 pi over 4. So if you need to draw it, go ahead and draw it. This is going to be pi over 6, so 1 root 3 and 2. So we know that tangent is going to be 1/2 plus tangent for 3 pi over 4 is going to be -1. Whoops, I'm sorry, root 3. 1 over root 3 plus a -1, all divided by 1 minus 1 over root 3 times -1. Okay? If we just rewrite that with less symbols, we're going to have this right here, 1 plus 1 over root 3. And this is what I meant earlier when I said sometimes it looks really complicated and messy. I'm okay with you leaving it like this. I don't need you to do any more. It just becomes so messy that you lose sight of what you were even doing. So I'm okay with you leaving it in this form. Okay. All right. Then we have the double angle formulas. If you're feeling like that was already a lot, I would go ahead and pause here for a little bit, work through some of those problems in the homework, or do some practice problems before moving into this. The double angle formulas are going to be when you have sine of 2 theta, or cosine of 2 theta, or tangent of 2 theta. Okay? That is when you use them specifically. You won't use them for any other scenario. We'll go ahead and start with this example using tangent, um, and then kind of move into some of the other ones. If tangent of gamma is equal to 0.5, evaluate tangent of 2 gamma and tangent of 4 gamma, again without a calculator. Okay. So really, we're already being given a lot of information. I have my tangent 2 theta equation on the far right. Let me go ahead and rewrite it over here. Tangent 2 theta equals 2 tangent theta over 1 minus tangent squared theta. Okay. Sometimes I just have to make sure I'm copying things down right. Now, we have theta to be 0.5, so all we need to do is plug in right now. We know that tangent of theta, or in this case gamma, is 0.5, so we'll go ahead and plug in 0.5, 1 minus 0.5 squared. All we need to do is simplify. We have 1 over 1 minus 0.25, so we have a final answer of, let's see, 4/3. Okay, that's going to be the answer for 2 theta, or gamma, I guess I should say. Okay, if we want 4 theta, think about this, right? What we're really saying is we want tangent of 2 times 2 theta. We already have 2 theta. We found it to be 4/3. Okay. So what we're going to do, if we want tangent of 4 theta, what we really want is 2 times tangent of 2 theta, which we already have. We found this just now. Okay. So all we need to do is plug in 4/3 and we can find that solution. So we're going to have 2 times 4/3 all divided by 1 minus 4/3 squared. Doing a little bit of math here because of fractions, we have 8/3 over -7/9, which is going to turn into 72 over 21, which simplifies, sorry, -72 over 21 to -24 over 7. Okay. Let's take a look at this next one. Again, without a calculator, simplify cosine squared of 22.5 minus sine squared of 22.5. What you'll notice is if you look back to your double angle formulas, you have a double angle formula that is cosine squared minus sine squared. Okay. The good news is we also have theta. We have theta as 22.5. So what you should immediately see is, okay, this whole expression is going to be equal to cosine 2 theta. This whole expression is equal to cosine 2 theta. And we know theta is 22.5. Okay. So if we use that knowledge, we would say cosine of 2 times 22.5, that's going to be cosine of 45. Well, you know what that is, right? We've done that plenty of times. We're in the first quadrant of the unit circle and we're at root 2 over 2. So all of that is equal to root 2 over 2. Let's take a look at the next one. Now we're being told a cosine value and where it is on the unit circle, and we want to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. My suggestion to you is to always draw the triangle, even if you think it's silly and you don't need it. I would do it anyway. I always do it, even though I know what my values are going to be. Okay, I have a cosine, so that's a -1 over 4. I need to find my y value. Whoops, sorry. Okay, so I need to find this. It's going to be negative root 15, right? This is going to be the Pythagorean theorem. We know how to use that. And now I have everything I need in order to find sine of 2 theta and cosine of 2 theta. Now, sine of 2 theta only has one option. Okay, it is going to be 2 times sine theta times cosine theta. Unfortunately, we just have the one option for her. We'll go ahead and plug in what we know. Okay, we're going to have 2 times sine, which is negative root 15 over 4, times cosine, which is -1/4. Okay, so that's going to give us 2 root 15 over 8. Sorry, definitely not 8, definitely 16. And then our actual answer will be 15, root 15 over, now that's 8. I am just making stuff up today. Okay, so that's going to be sine of 2 theta. Sine of 2 theta. We have a variety of options for cosine of 2 theta. Let me scroll back up to show those to you. You can use any of the three. Pick one that you like and go with it, right? It does not matter which one you use. I am just going to use the first one um, for no particular reason. I'll just use the first one. So we have cosine 2 theta is equal I already forgot what it was. Let me scroll back up. Cosine squared minus sine squared. Cosine squared theta minus sine squared theta. Okay, we have negative 1/4 squared minus negative root 15 over 4 squared. And now we just simplify, right? We're going to square, so we have 1 over 16 minus 15 over 16. That's going to be negative 14 over 16. Or if we simplify further, negative 7 over 8. Okay, and that's going to be cosine of 2 theta. Now, if you wanted to, you could use the tangent rule to find tangent of 2 theta. We also know that tangent is sine over cosine. So I'm just going to take my sine over cosine and find tangent of 2 theta. That's going to be root 15 over negative 7. Now, before you wonder where did the eighths go, they both have a denominator of 8, which means they both would cancel out. So I'm really only worried about the numerators when I do this, okay? So that would be sine, cosine, and tangent, all of 2 theta for this question. All right, now let's talk about reduction formulas. I do want to point out that reduction formulas are not going to be that important for us, okay? They are going to be very important in calculus 2. So I'll just introduce them here. I'll tell you that they exist. You're not really going to worry about it for another couple of semesters, but they will come back in Cal 2. Okay, so Cal 2. The power reduction formula is really just to get rid of a power, right? It allows you to go from a square to just a double angle, which can sometimes be really helpful. We do that by pretty much switching things around. So notice that we have switched how these are set up. Okay, we pretty much added the one to the other side, and that was really it. And then in order to completely get the x squared, the cosine x squared on its own, we divided by 2. So cosine squared x equals 1 plus cosine of 2x, all divided by 2. Again, not something that I'm going to expect you to know or use. It just will come up when we do Cal 2. The reduction formula for sine is actually really similar. The only difference is that you are subtracting in the numerator. So it still uses cosine. You are just subtracting. Okay. All right, we're done with that. We won't use it, but you've now seen it. So if they ask, you can tell them I showed it to you. Now we need to talk about the half angle formulas. Okay. Um, they can be derived from the power reduction formula. We don't need to go into the detail of it. And all I really need you to focus on is that there's a plus minus. Okay. That means you need to pay attention to the quadrant of the half angle. Okay. The quadrant of the half angle. That will determine if the root is positive or negative. This sometimes even gets me, so really pay attention to it. If I end up making a mistake in here and you notice it, please let me know. Okay, I'm gonna do my best to get it right. Now, we want to find all 6 values of angle x if we're being told that it's in this interval and cosine of 2x is the third. Now, the first thing that you need to do is look at the interval. If it's saying that the interval is for angle x, which it is, this is the interval for x, right? It also says that right here. If you want the interval for 2x, you need to multiply it by 2. Okay, so the interval we are actually working with is going to be pi to 2 pi. So we're on the bottom half. Okay. But then we're also being told that cosine of 2x is the third. So that tells me that I'm going to be over here somewhere, right? Because cosine is positive. All right. I just needed to make sure that we understood that. And if we have questions, we can talk about it more. I think it comes back up in 9.5. All right. Now we can use the double angle formula from earlier to find the remaining trig values. What do I want to start with? Let's start by using probably one of the ones that only use sine or cosine, since we have to find them one at a time. So we'll start there. And again, you can pick whichever one you want. So I will do 2 cosine squared theta minus 1. We'll do that. We know that cosine 2 theta is a third, so I'll plug it in for cosine of 2x, and then, oh, I should probably use the same variable, huh? I'll use x all the way around. And now we solve. So I have 2 cosine squared x minus 1. I need to add the 1. I need common denominator, so I have a third plus 3 over 3, which is 4 thirds. I need to, we'll go ahead and take 4 divided by 6 and take a square root. So that's going to be negative 2 over root 6. And for secant, it'll be negative root 6 over 2. Now, if we want to find tangent, we can just take sine over cosine. Okay. And so for tangent of 2x, I will take root 2 over root 6, all divided by negative 2 over root 6, which is going to leave us with root 2 over negative 2. All right. That is how you would use the double angle formula to find all the 6 trig function values for the single angle. And now we practice. So we are going to be working with a variety of the different equations that we've been working with so far, and it kind of just depends on what we need to do and what we're going to use. So I'm going to look at this first one right here, and I think about if it's a double angle or a half angle, and I think it's a double angle. So if I were to take pi over 8 times 2, that would get me pi over 4. So I'm thinking this is a double angle. um, the half angle in question is in quadrant 1, so I do want to keep that in mind. That makes that cosine value a positive cosine. Okay. Now I have 1 plus cosine theta over 2, and the theta that I'm interested in using now is pi over 4. So I know that I have 1 plus root 2 over 2 all over 2. Okay, I'm okay with you leaving it like that. You do not have to simplify further for my class. If we look at this one, I think this is also a half angle. If I double this right here, I would have 22 over 12 or 11 over 6. So I think what we're going to do is use the half angle formula. 11 pi over 6 is in quadrant 4. That's going to be a positive cosine value. So I'll go ahead and use the positive in my root. Okay. That's going to be 1 plus cosine of 11 pi over 6 and all divided by 2. So if I simplify that, I have 1 plus, I know my information for pi over 6, that's a 30-degree triangle. So that's going to be, let's see, root 3 over 2 all over 2. Okay. Again, you can leave it just like that for me. Okay. Let's take a look at C. We got 7 pi over 12. I believe we did that one earlier. Okay. So we know that that could be 3 pi over 3 plus pi over 4. So we're going to do the tangent sum equation. That's going to look like this. We'll have tangent of pi over 3 plus tangent of pi over 4, all divided by 1 minus tangent of pi over 3 times tangent of pi over 4. The tangent for pi over 4 is a 1. That's pretty something that we've been pretty good about knowing. For pi over 3, that is a 60-degree triangle. So that's going to be root 3. Okay, so I have root 3 plus 1 all over 1 minus root 3 times 1, right? So I don't really have to write that one, so I'll go ahead and erase it for my final answer. And then I have this for tangent of 7 pi over 12. All right, and move on to the top here. We have sine of 75 that screams half angle. I'm thinking 150 divided by 2 is 75. So 150 is in quadrant 2, and that means sine is going to be positive. So I'll go ahead and take the positive root for my sine. So that's going to be 1 minus cosine of 150, all divided by 2. I know that cosine of 150 is going to look like this. So that's going to be negative root 3 over 2, which makes that a positive. Okay. And you again can leave it in this form. All right, now we have tangent of negative pi over 12. I'm thinking if we double it, that's going to be negative 2 pi over 6, sorry, 12, which will be negative pi over 6. Tangent in that quadrant is going to be negative. So I'll go ahead and make sure to use my negative equation for that. So I'll have negative 1 minus the cosine of negative pi over 6 divided by 1 plus cosine of negative pi over 6. Okay, if I am in this quadrant, pi over 6, it's going to be negative 1 and root 3 with a 2. So my answer is going to be a negative square root 1. Let's make sure that my signs are good. 1 minus root 3 over 2, all divided by 1 plus root 3 over 2. Okay. Okay, if we keep going, now we have sine of 5 pi over 8. Thinking about when I double that, that would be 2 times 5 over 8, which would be 10 pi over 8 or 5 pi over 4. I'm thinking about sine. The sign would be negative in that section. Okay, so I'll go ahead and use my negative equation. 1 minus cosine of 5 pi over 4 all over 2. I know that that's going to be 1 minus the square root of 2 over 2. I know cosine is negative in that quadrant, so that's going to be a double negative, which will become positive, all over 2. Okay. And in this one, my root is not quite covering everything. I do want to make sure the root covers everything. Okay, let's move on to the next page. Now we have sine of negative 13 pi over 12. Mix it up. I'm going to change colors over here. Do blue. All right. So now if I double this, I have negative 13 times 2 pi over 12, negative 26 pi over 12, which is going to yield, let's see, um, dividing by 2, negative 13 pi over 6. So I do know that that's on the unit circle. If I'm going backwards, um, that means I might want to find a coterminal angle or the reference angle. So I'm going to go ahead and add um, for 4 pi. So 4 pi, just so I have the reference angle for myself. You don't have to do this if you don't want to. That'll be 24 over 6. And so doing that math, that's going to give us, let's see, 11 pi over 6. Okay. And if I am not mistaken, we did that one earlier already. We did. Yep. So, but now we're doing it for sine. So all of that is to say that we are working with 11 pi over 6. 11 pi over 6 is over here in quadrant 4, and sine is going to be negative. Okay. Now, for our sine equation, we will go ahead and plug in what we've got. So I said it was negative, so square root of 1 minus cosine of 11 pi over 6. Looks messy. Oh gosh. Cosine 11 pi over 6 all over 2. And we'll go ahead and simplify 1 minus. So 11 pi over 6, that is going to look like this. Okay, but remember that sine would be negative. In this case, cosine of 11 pi over 6 is positive. It's going to be root 3 over 2 all over 2. Okay, I'm looking down at the next one, 165 degrees. Okay, if you double that, you will get, so this one, you could go either way. You could double it, and if we doubled that, it'd be 165 times 2 to get 330. Or you could do a sum and difference, which is actually what I did on mine, even though I think the goal was to use the half angle formula. So I'm going to use the double angle or the sum identity. So I know that 45 plus 120 is going to get me 165. We'll just mix it up a little bit. I'm working with cosine, so I have cosine of 45 times cosine of 120 minus sine of 45 times sine of 150. Okay. I know that cosine of 45 is root 2 over 2. Cosine of 120 is negative 1 half. Okay. And then sine of 45 is root 2 over 2, and sine of 150 is root 3 over 2. So I'll have root negative root 2 minus root 6 all over 4. Okay. Oh, whoops. And then looking at these last two, cosine of 15 degrees, if we double it, that would be 30 over 2. That's going to be in quadrant 1, so cosine is going to be positive. So I'll use the positive root. I'm going to have 1 plus cosine of 30 divided by 2, or 1 plus, I know that's going to be root 3 over 2, all over 2. And finally, we have 22.5. I know that that's going to be 45 over 2. That's going to be quadrant 1. That means tangent is positive. So I'll go ahead and use my positive version. 1 minus cosine of 45 over 1 plus cosine of 45. So I will end up with, whoops, don't love that. Just deleted everything. Oh, didn't delete too much. I had 45 degrees. So let's see, we had 1 minus cosine theta over 1 plus cosine theta, which was 45. I have 1 minus root 2 over 2 over 1 plus root 2 over 2. Okay. At the bottom, we have sine value, and we are being told that cosine is greater than 0. So we just need to draw a triangle to find the remaining um, trig functions. Again, I encourage you to draw the triangle even if you feel like it's silly or you don't need it. Sometimes it just helps to have it in front of you. Cosine is positive, sine is negative. We are going to be over here in quadrant 4. Okay, sine -1 over 2. That means x is root 3. And now we have everything we need. So that means cosecant of theta is going to be -2. Cosine of theta is root 3 over 2. Secant of theta is 2 over root 3. Tangent of theta is -1 over root 3. And cotangent theta is negative root 3. Same situation for B, it just looks a little bit different because now we are working with cosecant and cotangent instead. But we know that cosecant is the reciprocal of sine. So sine theta, we immediately know is going to be 1/5. And if cotangent is negative, that means we're going to be in quadrants 2 or 4. Okay, 2 or 4. If sine is positive, we know that we're going to be in quadrant 2. So if I want to go ahead and draw my triangle, I can, 1 and 5. If I find my missing side, I'm going to get -2 root 6. And now I can find the rest. So I know that cosine theta is going to be -2 root 6 over 5. Secant theta will be the reciprocal, -5 over 2 root 6. And tangent of theta will be -1 over 2 root 6, and cotangent theta will be -2 root 6. Okay. And last but not least, we're going to verify some more identities based on what we know now about all these additional rules that we can use. So we'll just go ahead and practice that a little bit. Okay. Now, if you look at um, the right-hand side, I might initially say I'm going to go ahead and rewrite that as 1 minus cosine squared theta because that's the Pythagorean identity. So that might be useful to me. So I'll go ahead and write the denominator with it. Okay. If I look over here, I see sine squared. Okay. So I'm thinking we have a half angle situation. So I'll go write HA, half angle. And that's going to equal 1 minus cosine 2 theta. Sorry, not 2 theta. Cosine theta over 2, all multiplied by 2. So I'll bring down the rest. All right, I'm going to notice that those 2's cancel out. So now I have 1 minus cosine theta equals 1 minus cosine squared. Oh gosh, I did it again. I'm mixing around all my variables. Pretend that all these are the same. Let me go in here and change these to x. Sorry. Okay, I'm actually going to cross multiply, so I'll bring that over to the other side. So I have 1 minus cosine x times 1 plus cosine x equals 1 minus cosine squared x. And this right here, when FOILed, will equal 1 minus cosine squared x. That equals the other side, so we have verified the identity. Okay. Taking a look at this next one, I don't really know which side is more complicated, so I might just start on the left and see what happens. Okay. I see cosine of 2x. My instinct is to rewrite that as cosine squared x minus sine squared x, because now I can rewrite that as two separate fractions over cosine of x squared equaling this other side. So that would be 1 minus tangent squared of x equals secant squared x minus 2 tangent squared x. I'm thinking I should combine these tangents. So I'll go ahead and do that. Um, I'll bring the secant over. So I'll say 1 minus secant squared x equals tangent squared x minus 2 tangent squared x. And then I have 1 minus secant squared x equals negative tangent squared x. That happens to be a Pythagorean identity. So that right there is verified, right? I could move it around slightly so that it matches better. So I could say 1 plus tangent squared x equals secant squared x. And that way I can really see that it's a Pythagorean identity, but either of those would be a good stopping point. And then we have our last one. You'll notice that that one is a quadratic of sorts, right? It's a power of 4, but it can be factored. Um, so it's going to be cosine squared x plus sine squared x and cosine squared x minus sine squared x. Okay. We know this is the Pythagorean identity, so that equals 1, which just leaves us with cosine squared x minus sine squared x, which is equal to cosine of 2x. That is an identity, and that works. So therefore, we have verified. All right. I know that this was a long video. Please, hopefully you watched it in pieces and did not watch this all the way through. Take your time with this material, practice it.